You learned about engine problems, engine teardown, part cleaning, and part measurement and other aspects of engine service in other videos. This video will summarize overhaul of an engine short block. You'll learn how to properly install the crankshaft, main bearings, pistons, rings, connecting rods, piston pins, rod bearings, cam bearings, and other components into the cylinder block. The video is designed to give a close-up demonstration of the procedures for short block assembly, as if you were watching over the shoulder of an experienced engine technician. When used in conjunction with the textbook, the video will help you pass the 2 ASE engine certification tests. When working on an engine short block, remember how important it is to make sure that all parts are within factory specs. The slightest mistake could cause an engine to self-destruct. The pistons must harness the tons of combustion pressure and then push down on the connecting rods. The rings must prevent the high pressure from leaking past the pistons, and they must also keep oil out of the combustion chamber. The rods must transfer piston thrust to spin the crankshaft. The rod and main bearings must keep everything turning freely while spinning at very high speeds. Part clearances are measured in 1/1000th of an inch, or in thickness comparable to a human hair. By using recommended procedures and quality parts, you can do an engine rebuild as good as new, or even better than new. To begin block preparation, use a straight edge and feeler gauge to check for main bore alignment. If a 1 1/2,000th gauge will slide between the straight edge and main bore, the block would have to be sent to a machine shop for line boring. Rotate the block over and use a straight edge to check for deck warpage. Try to slide the feeler gauge between the cylinder block and the straight edge. Check in several locations across the top of the block. If the block is warped, you can send it to a machine shop to have them resurface the deck. Otherwise, head gasket leakage could result. To determine piston to cylinder clearance, first mic the piston skirts. This was explained in the previous measurement video. This will let you calculate piston clearance by comparing it to cylinder bore diameter measurement. You can mic the cylinder with a telescoping gauge like this one, or a dial bore gauge. An outside mic is needed to check the length of the telescoping gauge, which equals bore diameter. To find piston clearance, simply subtract piston diameter from cylinder bore diameter. Here, a technician is using a dial bore gauge. By sliding it up and down in the cylinder block, you can measure cylinder taper. Normally, a cylinder will wear more at the top than at the bottom. By rotating the gauge sideways in the cylinder and comparing it to the last reading, you can also check cylinder out of round. There are several types of hones that can be used in a cylinder. The type of hone you use will depend on the cylinder condition. This is a brush hone. It is used in the cylinder that is in good condition. It will texture the cylinder wall to aid ring sealing. However, it will not true the cylinder. It might be used after block boring, for example. This is a flex hone. It has rigid stones mounted on spring-loaded arms. It is used in a cylinder with slight wear. The stiff stones will not only texture the cylinder, but will tend to true the cylinder slightly. This is a rigid or sizing hone. It has stones that are mounted so they extend straight out. This allows a sizing hone to remove small amounts of taper and out of round from a worn cylinder, as if you were boring the cylinder slightly. The pistons would have to be knurled to make up for the material removed with a sizing hone. Here is the adjustment that extends the stones out against the cylinder wall. To use a hone, mount it in an air or electric drill. Lubricate the hone with cutting oil or WD-40. Push the hone down into the cylinder and spin it with your drill. Move the hone up and down fast enough to try and produce a 45-degree crosshatch pattern on the cylinder. To avoid damage, do not pull the hone out of the cylinder or push it down too far while spinning. After honing, inspect the cylinder. You should have approximately a 45-degree crosshatch angle to make sure that rings seal properly. After honing, it is critical that you clean the cylinder block to remove any honing grit. First, wipe the cylinder bores down with soap and water. Scrub inside the cylinders all the way from the top to the bottom. The soap and water will help lift any hone grit out of the crosshatch marks and remove them from the block. After washing, wipe the cylinders down with a clean, dry rag. If you fail to remove all the honing grit from the cylinder's hones, the grit can act as a grinding compound that can wear bearings and other engine parts upon engine operation. Cleaning this material out of the block is very important. After wiping the block dry, you should finish the job by wiping down the cylinders with a clean rag soaked in oil. Pour the oil onto your shop rag, then wipe the cylinders down with the oiled rag. The heavy motor oil will pick and remove any remaining grit inside the hone marks. The oil will also lubricate the cylinders and prepare for piston installation. You should also clean the crankcase thoroughly as needed after honing. Always remember the critical importance of cleanliness during engine assembly. The tiniest bit of debris can cause serious damage to engine parts after engine startup and operation. To install freezer core plugs in the block, first check to see that you have the correct size freeze plug. Fit it into its hole and make sure it fits properly. Wipe non-hardening sealer on the outside diameter of the new freeze plug. Also, sand and wipe the block bore opening clean. Spread the sealer all the way around the outside diameter of the plug. This will help prevent leakage. Next, use a driver or an impact socket and a brass hammer to force the plug into the block. Make sure the plug is installed perfectly square and that it's flushed with the top of the block bore. If installed too deep or too shallow, the freeze plug could leak upon engine startup. This could cause a time-consuming R&R of the freeze plug. Next, you must remove and install cam bearings. This is a special cam bearing driver. It has a special expandable head and drive rod that will allow you to easily remove and install cam bearings. It also has an Allen wrench for opening and closing the drive head. To remove cam bearings, turn the adjustment screw on the tool to close the drive head. Insert the tool into the cam bearing. Then, use your wrench to expand the drive head out against the cam bearing. Hammer lightly on the tool to force the old bearing out of its bore. Lift out the old bearing and repeat on the other cam bearings. To install new cam bearings, fit the new bearing onto the driver. It is critical that you align the oil hole in each cam bearing with the oil hole in the block. These holes allow engine oil to enter the bearings to prevent part damage. With the oil holes aligned, drive the bearings squarely into the bore. Hammer on the tool to drive it in until installed properly in the bore. Then loosen the tool and remove it. Double-check the alignment of the oil holes. You should be able to see through the holes or pass a piece of mechanics wire through the block and the bearing. This is the most critical aspect of cam bearing installation. If the oil holes do not align, they will self-destruct upon engine startup. Repeat this on the other cam bearings. To begin crankshaft installation, make sure the main bearing bores in the block are perfectly clean and dry. Wipe them down with a clean shop rag. Also wipe down the main caps. They should be free of oil and grit. Make sure you have the correct replacement main bearings. If the crankshaft journals have been turned 10 under, then the main bearings must be 10 over to provide the correct clearance. When fitting the new bearings into the block, make sure the oil holes align. The main thrust bearing must also be installed in the correct bearing bore in the block. The bearing tab must fit into the notch in the block. Fit the clean, dry bearing into the block and press it down with your thumb or fingers. Make sure the top of the bearing is flush with the top of the block. Also, fit the matching main bearing into the correct main cap. Again, the tab must fit in the notch in the bearing cap, and all parts should be clean and dry at this time. When installing the rear main oil seal, make sure the sealing lip faces the inside of the block. If installed backwards, the rear seal will dump oil out the back of the block after engine startup. Parts should be clean and dry when installing the rear seal. Press it firmly down into the block until flush. Recheck that the sealing lip faces the inside of the block. To prevent oil leakage between the main cap and block, apply an approved sealer to the surfaces on the block next to the rear main seal. Apply a small amount of sealer to the block right next to the end of the seal. Sealer in this location will prevent oil from weeping out between the cylinder block and the rear main cap. Use your finger to spread the sealer out away from the seal towards the lip formed on the block. Next, fit the other main bearings into the cylinder block in the same way. Again, check that the tab on the bearing fits into the notch in the block. Also, make sure that the oil holes align. If the oil holes do not align, the bearings will starve for the oil and the engine will self-destruct. Make sure that all of the bearing faces are perfectly clean. Wipe them off if needed, then apply heavy assembly lube or motor oil to the face of all the bearings. Heavy oil will protect the bearings upon initial startup. It might take the engine oil pump a few seconds to circulate oil through the main galleries and crankshaft to provide positive lubrication for the bearings. Next, fit the matching main bearings into the bearing caps. Note how the bearing cap bearing does not have an oil hole. Oil it as you did the bearings in the block. Next, prep the crankshaft and ready it for installation. You should have already mic'd the main journals and the rod journals to make sure their measurements are within specification. If needed, you should have sent the crankshaft to a machine shop to have it ground and ready for assembly. Always blow out all oil holes. It is very easy for particles to collect inside the crankshaft and cause bearing damage upon engine operation. If needed, run a rifle brush through the oil holes. Next, wipe down all of the journals. Make sure they are perfectly clean to prevent rod and main bearing damage. If core plugs are provided in the crankshaft, remove them so you can clean the inside cavities in the crank. With the bearings oiled and after checking the rear main seal, carefully lower the crankshaft into the block. Next, you can Plasti-Gage the main bearings to check clearance. Plasti-Gage use was detailed in another video. Plasti-Gage is a wire strip of plastic-like material. It can be installed between the bearing and journal and compressed to measure exact clearance between the parts. To use Plasti-Gage, lay a small piece of the Plasti-Gage on the journal. It should lay across the journal as shown. Next, fit the main cap and bearing over the journal and Plasti-Gage. Screw down and torque the main caps to smash the Plasti-Gage between the journal and bearing. Remove the cap and compare the Plasti-Gage scale with the compressed, smashed Plasti-Gage material. Note that this bearing clearance is approximately 1.5 thousandths, which is a typical specification. Install the other main caps. Make sure that their arrows and numbers are installed properly. The caps should be numbered 1, 2, 3, starting at the front, and the arrows should also face the front. Use an accurate torque wrench to tighten the main cap bolts to specifications. The caps should be tightened in steps and gone over several times, increasing the torque value up to full specifications. If you fail to tighten even one of the main cap bolts properly, severe engine damage can result. It is a good idea to go over all of the bolts a couple of times to make sure all of them are tightened properly. To measure crankshaft in play, you can use a dial indicator. Mount the indicator on the crank as shown. Then use a screwdriver to pry back and forth on the crankshaft. This will make the dial indicator read crankshaft in play clearance. As you can see, this crankshaft shows about 3 thousandths in play, which is a typical specification. You can also use a flat feeler gauge to check crankshaft in play. To service pistons and rods, first organize a new piston ring on your workbench. All your oil rings and compression rings should be removed from their boxes and stacked together on the workbench. Read the instructions provided with the piston rings to assure proper assembly. To measure ring in gap, fit one of the compression rings into the cylinder block. Then, use a piston to push the ring down to the bottom of its travel. Using the piston will make sure the piston ring is square in the cylinder bore. Next, use a flat feeler gauge to measure ring end gap. The largest gauge that fits between the ends of the ring equals end gap. Compare this measurement to specifications provided by the manufacturer. If ring gap is too small, you'll have to use a ring filing tool to remove a small amount of material from the ends of the ring. If ring gap is too large, measure cylinder bore diameter again. The cylinder may be out of spec for the piston ring. Next, check ring group depth. Insert one of the new piston rings into its groove in the piston. Make sure the ring is recessed below the outside of the piston ring lands. Rub your finger over the ring to make sure that it's below the outside surface of the piston. This will make sure that the ring grooves are deep enough to accept the new rings. Also, check ring groove side clearance. Slide a specified size feeler gauge between the ring and piston. If clearance is excessive, replace the pistons or have the grooves machined for ring spacers. Next, you're ready to install the oil rings on the piston. Follow the instructions provided with the rings. Ring designs can vary slightly. The instructions will usually say how to butt the expander spacer together, and it will also tell you which side of the compression ring should face up. After making all your measurements, you're ready to install an oil ring. Most modern oil rings have an expander spacer and 2 thin oil scraper rings. The 3 of these components form the bottom oil ring. First, slip the expander spacer into its lower groove on the piston. It's very important that the ends of the expander spacer butt together. If they overlap, engine damage can result. While holding the expander in place with your thumb, slip one of the scraper rings into place next to the expander spacer. Spiral it around and fit it into place on the piston. We like to install the top oil ring scraper first. Then it will help guide the second oil ring around and into place into the groove. The ring should move as a unit once installed. You will have to space the ring gaps later. Double-check that the ends of the expander spacer are butted together and that the ring moves freely. Next, you're ready to install a second compression ring. First, make sure you have the ring right side up. Different types of markings can be used on the ring. This one has a small dot which must face up on the piston. If installed upside down, engine oil consumption and loss of power can result. Carefully open the ring as little as possible and slip it into place on the piston. It should move freely once installed. Next, install the top compression ring. Check its markings to make sure that it is facing right side up, then carefully spread the ring and slip it down into its groove. Do not overexpand the compression rings because they are brittle and can break easily. If one is available, you can also use a ring expander to install the piston rings. It is simply a special set of pliers designed to use on the piston rings. Fit the ring into the jaws. Then set the adjustment nut so that you do not over-open the ring and snap it. Once the rings are installed, you must locate the ring gaps away from each other and next to the ends of the piston pin. Proper ring gap spacing will reduce blow-by and will increase engine power. Most automakers recommend spacing the gaps 180 degrees away from each other. Next, you are ready to install the rod bearings in the rods and rod caps. Make sure the connecting rod bores are within spec size, are perfectly clean and free of oil. Also, make sure you have the correct rod bearings for the crankshaft journal measurements. These are standard bearings, which means the crankshaft should be of mic'd standard. As you did with the main bearings, fit the rod bearings into the connecting rods and the rod caps. Make sure all surfaces are clean and dry and that any oil holes align. The tab on the rod bearing should fit into the notch in the rod and rod cap. Use your fingers to force fit the bearing into the rod. The bearing should be held in place by the pressed fit. To install the pistons in the cylinder block, fit rod bolt protectors or pieces of hose over the rod bolts. This will protect the crankshaft journals from grinding and scratching as the piston and rod are slid down into place. Oil the rod bearings with heavy motor oil or bearing lube. Also, lubricate the piston skirts and piston rings. Oil is needed to protect these parts upon initial startup. Wipe the oil all around the piston and piston rings. Next, double-check ring spacing. Make sure your gaps are staggered away from each other and that they are aligned with the ends of the piston pin. When you mount a rod in a vise, make sure you use lead vise caps. The slightest mark on the rod could cause the rod to fracture and break in service. Always use lead vise caps. Next, use your ring compressor to force the piston rings into their grooves. Make sure the compressor is square on the piston before clamping it down around the piston and rings. Rotate the corresponding connecting rod journal down or to BDC by turning the crankshaft by hand. This will give you plenty of room to guide the rod down over the crankshaft during installation. Check the piston markings. Make sure the piston faces the right direction in the cylinder block. The mark or arrow on the head of the piston normally faces forward. Also, make sure the rod numbers face correctly in the block. Oil the cylinders to prepare for piston installation. Slowly lower the rod and piston into the cylinder. Again, double-check piston and rod markings. If turned backwards, engine damage can result. Tap on the top of the ring compressor to square it on the block deck and aid ring installation into the cylinder. Then, use a hammer handle to tap the piston down into its cylinder. If the rings catch on the cylinder wall, do not force the piston down, or you will damage the piston and rings. Tap the piston down and guide the rod over the rod journal. Then, remove your rod bolt protectors. Double-check that the rod bearing is still in place. Inspect the tab on the bearing to make sure it is installed in the notch in the rod. Oil the rod cap bearing and then install a cap on the rod. The tab on the cap should be on the same side as the tab on the rod. The numbers on the cap and rod should also be aligned. If the cap is installed backwards, bearing and crankshaft damage can result. Install the rod nuts with the original side facing down. Spin them on by hand, and you're ready to torque them to specs. You might also want to Plasti-Gage at least one of the rod bearings to check bearing clearance. This was described with main bearing service. Start out by torquing each rod bolt to about 1/2 torque. Torque both nuts to 1/2 specified torque. Then, torque the rod nuts to 3/4 full torque. Torque them to full torque 2 or 3 times as a safety measure. A trick to check piston ring installation is to rotate the crankshaft with a torque wrench after installing each piston. If any of the pistons increase the torque too much, there is a problem with the rings that should be checked out. To check rod side clearance, insert the specified thickness feeler gauge between the rod and crankshaft cheek. If clearance is excessive, there is a problem with the crank or the rod.